Okay, third time may be the charm. Not sure, hope so. I'm kind of looking stupid here along the highway, but I've always been told to play to my strengths. This is a zone map for the field that I've taken videos that have been put up on Facebook and YouTube. This particular field has 8 different distinct soils in it. And I'm going to zoom in so you can see, hopefully, the legend of this layout map. It's got a zone 1, dark green, 2, lighter green, 3, it's got 4, yellow. It's got a zone 10 is red, assault right to the surface. Zone 16, that umber or brown, it's got gravel. Real close to the surface. Not good enough to mine. 17's depressional, which you can lose in a wet year or maybe not even plant. And it's got 19, which is sandy soil, sits higher in the landscape. Can run into potassium and sulfur deficiencies in the early growing season if those nutrients aren't applied. And a zone 21, which has soil, which is a soil that has salt, but it's a little deeper in the profile. Hopefully you can see the acres of each of those soils. Now I'm going to move on to what we call the resample map to show you the points where the samples are pulled. I'm going to focus on that zone 4. It's yellow, it's easier to see the points. You got point 3, point 10, point 0, and point 11 on zone 4, where we gather samples and then we send those off for analysis. And that works for every soil. Zone 17 has, over here on the east side, a point 1. Then in the north, at north central, 22, 23, and I'm not sure what that point is underneath that 17, that white 17. That's a sample point. We lost the thing. So we're going to get a soil sample for every soil. Then we put it in a spreadsheet that's proprietary to our business. We developed it. And it shows what soil zones, how many acres, the pH. The pH in this field varies from 5.4 to 8.2. Organic matter varies from 1.2 in that gravel to 3.5 in the high in that zone 21. Salty soils can be high in organic matter. They just can't produce because of the salt. P and K, that's the nutrients which are non-mobile we kind of focus on. They vary from 9 on that sand to a high of 36 in that depression, and that's fairly common. If you see that zone 10, it's got a Olsen phosphorus of 30, which means we've been putting it out there and never harvesting anything off of it. Potassium, the sand is the lowest at 118. The eroded knobs, them zone 4s, 135. The gravel, 154. None of that is a surprise. It's all based on, a lot of it's based on organic matter and how the land has been abused prior to this, or actually what the land is, the soil is. So then we come down and then we establish a yield goal for each soil. The yield goal ranged from 90 to 185 with an average of 152. Now in the gravel at 90 and the sand at 125 and that salt at 90, I don't know that we're going to make those. But I think we can make that 185 in zone 1, 170 in zone 2 is going to be tight. But it was a dry year, 8.42 inches of rain on this field from April 1st to September 1st. So what's here is amazing. So now we're going to go down and I'm going to try to keep my shadow out of here. Here are the nutrients. The starter, flat rated at 5, 1152.0. Fall applied, anywhere from 0 in the places that can't use it or don't need it, up to 125 where they're short. They've been overproducing They've been shorted of those nutrients for years. This is land that they're going to own eventually, and this is part of their retirement plan, is to maintain the nutrients, to put the money in the land, so when they go to rent it, they have a good base for that. 4600 and the AMS 210024 were spring applied. You notice that we put AMS on that gravel and in that sand because of early sulfur deficiency potential in those two soils. And then let me go back to the potassium. We'd also put 125 pounds of 0060 in that gravel and 150 in that sand because of potassium deficiency. And once a plant, particularly a corn plant, develops potassium deficiency, that plant's committed to whatever it's going to achieve on that. Then we come over here. We have 2800 at 10 gallon rate with some herbicide, and then the seeding rate varies anywhere from 16 in that gravel up to 30 in that zone 17. Zone 1 is 28, 2 is 26, those eroded knobs is 23, the salt is 18, the sand is 18, and the subsoil salts is 23. Then we come down and you can look and see the cost is built into the spreadsheet we developed. So you have your seed costs varying from $47.80 up to a high of $89.63 based on $239 per bag. Fertility, and this is total fertility cost, varies from $55.94 at a low up to $105.52. So you're moving your nutrients by type and by amount to where you need them to raise this particular crop. Now when we come down to the bottom, here's the bottom. This is where your estimated cost of production per bushel by zone is. And you can see your better zones have a lower cost of production. Surprise, surprise. Your potential to raise more bushels in those poor soils will always trump whatever management you do on the yield you can raise on those good soils will always trump the poor soils, because the poor soils, you can't ever yield your way to a low cost of production. You can manage your way to the lowest cost of production possible, but the goal is to produce one harvestable ear per plant. And we've achieved that in that gravel and in that sand and in that salt. So then once the crop comes off, we can come over here and put the actual crop yield by zone in for the client, and they can get their actual cost of production per bushel for each field. Then for $50 per crop, we'll run a report that gives them their actual cost of production and estimated cost of production per bushel. So they have those numbers when they go to marketing and that sort of thing. They know what their costs are going to be. They just need to learn to manage the seed and fertilizer, putting it in the right soil at the right amount. This is Francis Schaefer, Precision Soil Management. I hope you enjoy this.